I read this paper twice. The first time, I thought I was misreading the numbers. The second time, I checked the corresponding author's email address. It was real. What if I told you that Mars isn't dry? That the water we thought was gone 3 billion years ago, most of it is still there. Not as ice, not as vapor, as liquid, underground. This isn't a leak from somebody's lab. This is published, peer-reviewed work from August 2024, and the team behind it had to fight for almost 2 years to get the math past reviewers. I'll show you exactly where they found it, what made them sure, and why it changes what we thought we knew. Not adds to, changes. But to understand why this paper is heavy, we have to start with the thing we got wrong. And we got it wrong for 60 years. July 14, 1965. NASA's Mariner 4 probe sweeps past Mars, 6,000 miles above the surface, and beams back 21 photographs. The first close-ups of another planet ever. They show craters, just craters, pockmarked and gray, nothing alive on them anywhere. President Johnson is in the White House 2 weeks later, holding the printouts. He calls the achievement awe-inspiring. The scientists who delivered the images? They look more shell-shocked than proud, because they expected something else. For the next 30 years, that's the Mars we had. A bigger moon, dead, cratered, done. Then in 2008, NASA's Phoenix lander digs a few centimeters into the Arctic soil and finds something white. It melts. Water ice. The headlines explode. We rediscover Mars. Over the next decade, more pieces show up. The Mars Reconnaissance Orbiter maps ancient river channels. Curiosity finds clay minerals that only form in standing water. Perseverance lands in a dry lake bed. But notice, past tense, every single time. Mars had water. Mars used to be wet. Mars lost its oceans roughly 3 billion years ago when the atmosphere thinned and the planet froze. Liquid water today, right now in 2026? That was never on the table, and that's exactly where the story should have ended. It didn't. In May 2018, NASA does something different. It launches a probe that's not a rover. No wheels, no cameras pointed at rocks. Just one stationary lander, 4 legs, 2 solar panels, and a single instrument that matters, a seismograph. It's called InSight, and the idea is this. If you want to know what's inside a planet, you don't drill, you listen. Earthquakes. Sorry, Marsquakes. They send waves through the planet, and those waves change speed depending on what they pass through. Hard rock speeds them up. Loose dirt slows them down. Water does something weirder to certain kinds of waves. And if you record enough of them, from enough different angles, you can build a map of what's underneath. InSight lands in November 2018 at a place called Elysium Planitia, which is basically the geological equivalent of an empty parking lot. Flat, boring, perfect. The seismograph deploys, the instrument starts listening, and for 4 years it just sits there, recording, quietly. Honestly, when InSight launched, I thought we'd get a clean map of the Martian core. Something elegant, something I could draw on a napkin. That's not what happened. December 2022. Dust has piled up on the solar panels. Power drops below the threshold. NASA tries to make contact twice, fails both times, and declares the mission over. Final tally? 1,319 Marsquakes recorded. The lander dies. The data lives. And the real discovery hasn't even started yet. August 2024. A paper drops in the Proceedings of the National Academy of Sciences. 3 authors. Vashon Wright at UC San Diego. Matthias Morsfeld, also at UC San Diego. Michael Manga at UC Berkeley. They've spent over a year picking through InSight's archived seismic data. The stuff that came in during the lander's last 6 months, but never got properly analyzed before the mission ended. They noticed something off. Specific kinds of seismic waves, the slower ones called shear waves, are moving through the Martian crust at speeds that don't fit any standard model. Not at the surface, not in the deep mantle, in the middle, specifically between 11.5 and 20 kilometers down. Solid, dry basalt, the kind that makes up most of the Martian crust, propagates these waves at one speed. Ice does it at another. Empty fractured rock, another. None of them match what Insight recorded. So Wright and his team start running combinations. What if the rock is porous and dry? Doesn't fit. What if there's a thin layer of ice? Doesn't fit. What if there's water vapor? Still doesn't fit. There's exactly one combination that does. Cracked, fractured basalt, saturated with liquid water. Not pockets, not ice. Liquid groundwater, filling every pore and crack in the rock, like a wet sponge frozen mid-squeeze. Here's the thing. This isn't them claiming they found an ocean. They're cautious, almost annoyingly so. The paper title doesn't say discovered. It says consistent with, because a real argument is still happening in the field. Another team published in 2025 said the same data could maybe work for clay minerals instead. But Wright's model fits cleanest, by a lot. Then someone on the team did the math on volume. The room went quiet. I'm imagining that part, but I'd bet money on it. Enough water to cover the entire planet to a depth of between 1 and 2 kilometers. Read that again. Not a thin film of moisture, not damp soil. A global ocean's worth if you could somehow extract every drop and pour it on the surface. We're talking more water than is locked in the Martian polar ice caps. More than what evaporated when the atmosphere left. More than the so-called missing water that planetary scientists have spent 30 years trying to find in space, on comets, in the solar wind. It was never missing. It was just deep. Here's what I keep coming back to. We never lost Mars's water. We stopped looking deep enough. And the reason we stopped was that nobody had the right instrument. Until a sad, dusty lander with one seismograph kept listening long enough to give us the data, years after it died. That's the part that gets to me, not the volume. The fact that the answer was sitting in an archive, on a NASA server, waiting. But here's where the picture gets messy. This isn't the ocean you're imagining. Forget what you're seeing in your head right now. Forget the dark cavern with stars reflecting off still water. Forget the underground sea, the Hollywood version. None of that is what's down there. What sits 11 kilometers under Mars is more boring and more interesting at the same time. It's an aquifer. If you've ever drunk well water on Earth, you know what an aquifer is. Even if you didn't know the word, a layer of rock with cracks and pores. The cracks fill with water. The water doesn't pool or flow as a river. It sits in the rock, the way coffee sits in a sponge. That's what Mars has. Just deeper than anything we have on Earth. 10 times deeper, give or take, than the deepest aquifer we've drilled into here. So is it an ocean? It is, and it isn't. It's an ocean in the sense that the math is oceanic. The volume is what an ocean is. It isn't an ocean in the sense that you couldn't put a boat on it. You couldn't dive in it. You couldn't film it. It's the messier kind of ocean. The kind that fills rock instead of basins. The kind that doesn't have a shore because there's nothing on the surface to have a shore against. This bothers some people. They wanted the cave. I get it. I wanted the cave too. But the volume doesn't care what shape water is in. And the next question, the one everyone asks within 5 seconds of hearing about this, that's where it stops being a story about geology. Is there anything alive down there? Real answer? We don't know. Nobody has been down there. Nobody is going down there in any of our lifetimes. So please don't quote anyone, including me, saying Mars has life. That isn't what this paper says. That isn't what any responsible paper says. But here's what we do know. On Earth, in the deepest mines we've ever drilled, in cracks in basalt 3 or 4 kilometers below the surface, there's life. Bacteria. Slow, ancient bacteria, weird in ways we're still cataloging. They don't see sunlight. They don't breathe oxygen. What they do is feed on chemistry that happens when rock and water touch. An entire ecosystem of these things, and we only started seriously studying them in the 1990s. Most biologists now think the total mass of underground microbial life on Earth might rival everything alive on the surface. If those conditions exist on Mars 11 kilometers down, water, warmth from geothermal heat, mineral chemistry, protection from radiation, and the new paper says they probably do, then this isn't a dead planet. It's a planet with a roof. The life isn't gone. The life would have moved. I'm not saying that's what happened. I'm saying it's now a question we have to take seriously. So when do we go drill there? Short answer? Not soon. Maybe never. The ExoMars Rosalind Franklin rover, launching in 2028 and landing in 2030, has the deepest drill any planetary mission has ever flown. It can reach 2 meters. 2. The Martian groundwater starts at 11 kilometers. We are off by a factor of 5,500. There are concept missions on paper for deep Martian drilling, but they are exactly that, paper. Even with infinite money, we're talking 40, 50 years. More likely never with the actual money we have. So we look at it indirectly. New seismic missions, better orbital radar, reanalysis of every byte of data we already have. Because if the answer to the biggest question about Mars was sitting in an old InSight archive, what else is sitting in some archive we haven't gone back to yet? The follow-up papers from Wright and Manga's team start coming out next year, in 2026. I'll be reading them the day they drop, and I'll cover the important ones on this channel. Subscribe if you want that. And in the comments, tell me this. If we ever did get a drill down there, 11 kilometers into another planet, what would you actually want it to find? I'm curious what you'd choose. I told you at the start I read the paper twice. Here's the part I haven't been able to shake. For 60 years we looked at Mars and saw a corpse. A dry, red, finished planet. 60 years of textbooks, of documentary voiceovers, of pop culture, all of it built on a flyby in 1965, where a tiny camera took 21 photos and we made the call. We were wrong. Not a little wrong. Way more than we thought. The water didn't leave. It moved. Down, under the rock, into the cracks, where it has sat in the dark for 3 billion years while we walked on the moon, built telescopes, sent probes, and somehow missed it. It was there the whole time. Maybe the best science isn't about finding new things. It's about realizing what we missed. And whatever else Mars is hiding, and there is more, there always is, we're going to read the data we already have a lot more carefully from now on.